All right, what we got? Where we at? Where you at? Who is asking? Sure, go ahead, and then I'll go this way.
4.1, number 40.
Oh, okay. We'll do that here in a minute.
Oh, we haven't gone over that?
Well, I mean, I'll remind you, I showed you a while back about how to find the intersection of two lines in the calculator. But we'll do it again. Yeah, I'll get this guy warmed up. Maybe we can just do this guy. Page 281, number 40. Yeah, you gotta do a little bit of work though.
Do you need a calculator?
Huh?
Do you need a calculator? Or
To do that problem, yes. I mean, not really, no, but they ask you to use one, so yes. While that's warming up, anybody else have a question? Yes? I thought, and then over there.
7, number 65. I know how to use the slope of the y.
65? All right. All right. So we'll do this one, then we'll do that graphing one. Guys, everybody. This is page 239, section 37, number 65. It says write the slope intercept. That's this guy. But you might have to use this guy to get there. This is 65, 37. Yeah, so what if you can't, you don't have to start here, you just have to eventually get there. All right? So this is the one, just to show you, this is the one that says -2, -4, and it goes through 2, -1. So you need the slope and you need a point. Well, you got 2 points. Which one do you have to use? You don't have to use either. Either one. Doesn't matter. Neither one of these is necessary. You just pick one. Why? Because they're both working the line. They both should make the line equation. Because the line goes through both of them. So you pick your favorite point. And between the two, you can find a slope. Because when they ask you to find the equation of a line, what 2 things do you need? Slope and a point. I got 2 points. I got abundance of points. Okay, I'll lock it. They do say put it in this form, but it doesn't have to start in this form. Start in this one, and then solve for y. So let's look at the calculator problem real quick here. I didn't bring any calculators with me, but just to remind you guys how to do this. Stay. Use this up here. Thanks, Texas. See if that's the right one. Yeah, okay, sweet. Ooh. There it is. Now, the problem with the problem you asked me about is it's not solved for y yet, either one. Okay, so in the book, let me just show it to you in case you don't have the book. This is section 4.1, number, who was it again?
Number 40.
Let's see if I can show it to you. There we go. Oh, look at the answers. I got the magic book. So number 40, it's this one. See how it starts off not solved for y yet? Why is that a problem? Because what button do you push to put something into the calculator to graph it?
Y equals?
Y equals. So the first thing you have to do, let's do a problem like that one. Now, the first part of this problem is to solve, let me just make one up real quick. solve it for y. Each one. So let me see. Let's try those two. So 1.4x minus 8.1. Now put it in here. So in that problem, you solve each one of those for y. I'm going to put that first line into y1. 1.4x minus 8.1. Is everybody cool with that?
How you put the X in here?
The little X button right there,
Where?
right next to the alpha button,
Hey.
anytime. And then y2, I'm going to make negative, remember there's your negative button, negative 3.2x plus 11. Now if I hit zoom 6, it'll take me to a standard window so I won't get all freaky stuff.
Why don't you say it that way?
Zoom 6.
Invalid what? Somebody was using this for statistics. I'll do it again. So here's my y equals. You put the two equations. These are not the two equations from that problem, by the way. That's your problem to do. I'm going to do this one. Solve for y, put the two equations in. Because that's what this thing does. It graphs the shit out of everything. So I put them in, and the answer is going to be, of course, where those two lines intersect. So how do I find where they intersect?
Do the box.
No, you don't have to do the box. Do second calc. Remember that? Everything on the top of the calculator is related to graphing. See how we got y equals, this is if you do statistics, you can plot the data. It's got windows, you can control how big the window is. It's got table sets, so you can control the table. If you want to see an XY table. And it's got calc. I want to calculate something right now, graphically. I want to calculate where those two lines meet. So it makes sense right now to hit second trace to get to calculate. And which one of those do I pick? No way. You gotta love that. 6 and 7 are calculus.
Do you get one?
Do what?
Sit down.
So number 5. And then I told you guys, I don't know if you guys remember this, but it asks for the first curve, and when you hit enter, it automatically bounces to the next curve, and then it asks you for a guess. So I told you, put the cursor right on the answer. Hit enter. Now it bounced to the second line, but you're right where they meet anyway. So it's saying second curve, see that? Enter. Now it says have a guess. Well, I put my cursor on the guess in the first place. I could just hit enter. I'll do it again. So that would be the answer right there. This point. So let me do that again. Second calc, intersect. I want to see where those two lines intersect. Just to show you, if I didn't put it on the answer, watch. First curve. I'm on my first curve. Enter. Ah, look how it bounced away the shit up there to the next curve. And yes, in math we call this a straight curve. We are weird. Second curve. Enter. Then it says, what's your guess? Okay, let me put my cursor on the guess. Enter. And that gives you the answer. You can use that even if it isn't freaky ass numbers. You can use that just to double check any problems you do. Like the problems on the test, for example. You can double check it with the calculator. Isn't that crazy?
Are you going to let us use a calculator on Thursday?
Test, yes. Yes. Quizzes, normally not. Haha. But you should know that by now. First test, no. But now I'll start letting you use them on tests, yes. The first test, I couldn't. That was math, 88, 90 stuff.
Sorry,
I'll do it again. So, you got everything, you got that in there, right, for y equals? All right, how we doing? Then you hit zoom. 6. That's a good thing to start with because it always takes you negative 10 to 10, negative 10 to 10. So you should get this picture. Whoa, a little too far. How we doing over there? You okay? Yes, okay. Give me some kind of feedback. Now hit second trace to go to calc. And we'll calculate the intersect, so just hit 5 for intersect. 5. So it asks for the first curve, so I'm on the first curve, enter. It bounces to the next one in my list. Second curve, enter. Then it says guess. Let me put the cursor over here on my guess, enter. And that, of course, is the point where the two lines meet, so that's the answer to that system of equations. Okay, see me after if you need some more. There are instructions in the green book. There is that calculator guide that's on my website that you can print out for yourself. You're surrounded by calculator help. You can also ask questions, and I'll show you again how to do stuff. I like it. Okay, anything else about the calculator while I have it up here? Oh no, I forgot it. Yes, sir.
Can we go over number 30?
Okay.
4.1.
4-1,
4.1.
number 30?
30.
Okay. So not a calculator one. Okay. Just bring that light back up. Say again? Yes. You do exactly what I just did. But you do it with those. You solve for y. And then you put those in. Okay. So I'm done with 40. But it's not my homework assignment. All right, so I'm sorry, which one, 30?
Yes.
Right?
30.
On number, in section 4.1, I got a question about number 30.
You said we have to go through 4.3 by Thursday?
Yes. Yes. We're all crazy. We only have one section left to do today, which is section 3.8. I got the practice test to give you. Tomorrow I'll have the answer key. The test is this Thursday. So number 30 says this. So plus 1, minus 1. Now, if I was going to let you do this using substitution, you could see how that would, I could plug that in here, go to town, but this is the section that says solve it graphically. So, what's the first thing I have to do before I start graphing stuff? Yes, so this one's in the proper form. Proper. Let me put this guy in the proper form. Because the 4x is positive, so I got to subtract it, so it cancels. Put negative 4x in front. The 18 is still positive. I didn't do anything to change the signs. Divide by negative 3. Now I'm going to change the signs. Was a Virgo, now it's Aquarius. No, so what's this? For some reason you guys you want to keep the negatives alive. You put one of them on life support. They kill each other. So let them die. And this is going to be minus 6 only. So now you graph this one. You graph this one. Are they going to intersect even before you graph it? Can you tell they're going to intersect? Why would these two intersect for sure? Their slopes are different, right? As long as the slopes are different, they will meet once. If the slopes are the same, they could either be parallel or they could meet everywhere, right? But here the slopes are different, so they got to meet once somewhere. So Now you graph them. I don't know if I want to. What's the question about them is? So if I graph the first one, what do you know about the first dude? This guy.
The y-intercept's -1.
Y-intercept's -1. And where do you go from there?
Down 1.
So -1. So then you go down 1 over 3. I could also go up 1, back 3. I like it. So there I am. Shwa. What about the other guy? Oh shit. -6. Bam. And I go 1, 2, 3, 4. 1, 2. Yay. So the answer is, I don't know why I did this all the way up. Don't stop here and go, there you go, Jeff. No. I ain't got to do your work. Tell me what the answer is. The answer is going to be... Cool. And you can check it. You can plug that in, make sure it actually works in both. No, yes? Room full of people I don't want to play poker with. I'll tell you that much. How you feeling? Yeah. Okay. Anything else from homework stuff? Yes.
3, 7, 55.
You're welcome. That's what it says, dude. I couldn't stop myself. 37 number who?
55.
55. Oh, okay. So it's got to be perpendicular to this line. What was it now? So this one, it says it's got to be perpendicular to this line and have this y-intercept. What does this tell me? B. So I know B is 6. I know my line. Is this the one you're talking about?
Yeah.
Okay. You're looking at it like, whoa. I know my line is perpendicular to this line. Is this guy in the right form to see what I need?
No.
What's wrong with it? Is y by itself?
Oh, yeah.
Yeah. What do I need to know about this line? I need to know his what? His slope. Mine is perpendicular to this dude. His slope is 2. So my slope is going to be negative 1/2. I love it. So you change it totally. You flip it and you change the sign. So now you just got to put those together in mx plus b form. You're done.
Oh.
Those are almost too nice to believe. If you understand perpendicular parallel, 43 through 58, very straightforward. Should be. If it isn't, yes.
What about the points, like number 50 and -3, 6?
Oh, okay. So it goes through the point -3, 6, and it's parallel to y equals 7. If you're parallel to y equals 7, what's got to be true about your equation? So how does y equals 7 look? What kind of line? Yeah. Go through there, right? So that's y equals 7. If I tell you something's parallel to this, its equation has to look like... So here, is this parallel?
Yes.
What's the equation of this line?
0, 1.
What's the equation? You're falling out, man. So think about it. Think about it. Think about it. Anything that's parallel to y equals 7 is going to have an equation y equals something. Right? They tell me that my line goes through -3, 6. -3, 6.
Oh, so it's just going to be y equals 6?
Yes, it's going to be y equals 6. So if I had a vertical line that went through this point, what would its equation be? Vertical line goes through this point.
-3.
X equals -3. Oh, shit. You could still use the y minus y1 thing if you wanted to on that, but that's a little crazy. Because what slope does this guy have? 0. Oh, it's parallel, so it's going to have 0 also. You could put a 0 in for m, you could put -3 in for x1, and 6 in for y1, and finally get to y equals 6 eventually. That would still work. Yes?
I think a little way to memorize the difference between point slope form.
Say again?
You have like a little way to memorize the difference between point slope form and then the other
Slope
one.
intercept, yeah. Well, I mean, so guys, I did kind of make a joke out of it because it is, math people, in this instance, we weren't very creative. We said, let's call that slope intercept because it's got slope in the intercept. Do you see what I mean? Yeah. Let's call this one point slope because it's got a point and the slope. So the name kind of gives it away.
Okay.
Yep. A lot of things. I love how some of you are like, I'm not amused by your answers. They really are getting old, Jeff. Not too damn bad. So believe it or not, we finished chapter 4. Let's do a couple of reviews, problems. You guys are funny. We finished chapter 4. 4:1 was graphing and finding where they meet. The look on your face. 4:2 was, although you I can't trust. 4:2 was substitution method, and 4:3 was elimination method. So let's do a couple examples, and then we'll finish out chapter 3. We still have to do 3:8. I kind of skipped it for a minute.
What's elimination?
So notice that this says use substitution. Now, if I just said solve this any way you want to, I would hope that most of you guys would use elimination. We're going to do the same problem with elimination in a minute. What does it mean? What's the first thing I need to do when I have to do something using substitution? Just take one of these and get something by itself. What's the only variable up there that I can get by itself without making fractions? That y right there. Yeah, that's what you look for. When they say do this using substitution, you're like, I'd rather use elimination. Too damn bad. Hope to God one of these has like a 1 coefficient. Anything else I would make fractions. And I'm pretty damn good at math. But if I don't have to make fractions, I'm not going to, because they're a place where humans make mistakes. So how do I solve this? For y, I just subtract 3x over. Negative 3x minus 2. Is that cool? And now what do I do with this? I'll tell you what to do with it. Yeah, you take this and you plug it in the other dude. So I can rewrite 2 as 5x minus twice this equals negative 7. So that's substitution. Very subversive. Very, in the dark of night, we replace it. Is that all right?
Yeah.
So solve one of them for a letter. Plug what you get in for that letter in the other dude. So use this information together with this information. And now together they made a better formula. Why is this a better equation?
You could simplify it.
Because I only have one variable. So I get 5x, help me out,
Plus 6.
plus 6x, plus 4.
Minus 4.
So I get 11x equals
Negative 11.
negative 11. Get out of there, 11. X equals 1. And I've got already this guy waiting. Y is negative 3 times negative 1 minus 2. 3 minus 2, so y is 1. 3 minus 2. What happens? Right? Once I know one letter, once I know one of the letters, I plug it into any equation I want to solve for y, but this is already solved for y. So plug it into this one, shit, yeah. But if you plug it into this one, it should still work. So plug in for x. X is negative 1. Plug it in. Negative 3, negative 1 is 3. Minus 2 is 1. So my answer will be negative 1, 1. What's true about that point? That's the point where what would happen? Where these two lines would intersect if I did graph them. That's why it's kind of best to write the answer as a point, because that's the idea. But if you just write these and circle them, I'm fine. I'm not going to freak out. Okay, does that sound familiar? We definitely did substitution method before. Now let's redo this same problem using elimination method. Get you out of the way. Turn your reader. You turn around. So let me write this over here. 3x plus y equals negative 2. 5x minus 2y is negative 7. Now if I want to use elimination, what do? What's the good way to use elimination? Do I want to kill the x's? Is that the good variable to go for? No, it's not the best choice. Would it work? Oh shit, yeah. But why is y easier? Because all I got to do to this guy, multiply this guy by 2, because then it would cancel with this guy. You can't just put a 2 here, because now you got a whole different equation. To keep the equation the same, you multiply the whole thing by 2. So what do you get? You get 6x plus 2y, yeah, there, equals negative 4. Well, this is going to look kind of familiar here in a second. And then divide by 11, I got x is negative 1 again. And then you can plug that into either one of these. Let's plug in the second dude, because we didn't use him before. If I rewrite the second dude, 5 times negative 1 minus 2y equals negative 7. This is negative 5, so I can add 5. Negative 2y equals negative 2. Divide by negative 2, and get y as 1 again. So I got the same answer, thank God. So elimination directly tries to kill a letter. Substitution very discreetly replaces a letter with something to do with the other letter. Yes?
I'm sorry, how'd you get the 2y again?
The which one? Oh, here?
Yeah.
So I took the first equation and multiplied both sides by 2. 2, 2, 2. Am I, huh?
Why is that?
Because what did I want here so it would kill this?
Oh, okay.
I wanted 2 there. But what's the only legal way to make that double? Is to double the whole damn thing.
Okay.
This equation and this equation are equivalent. They have the same answers. So I didn't change it. If I just put a 2 there, it's a whole different line. I've changed its slope. It's a totally different line. So the only way, if I say to myself, shit, if only that was a 2. Okay, double that sucker. It's a 2 now. Let that be awesome. Right? It's kind of nice. If only that was this. All right, make it that. Multiply by what you just said.
And that's if the variable is by itself, or...
Yeah, I'm trying to, there's too many letters, so I'm trying to set it up so that one of the letters will die when I add these two together. So always got to be opposite sign, same number. Yes, sir?
So if it was like 5 or 7, you would multiply, right?
Yeah, if this was minus 7, I would have multiplied this whole thing by 7. For the same reason. I'm trying to set it up so that one of the variables dies when I add the two things together.
And it doesn't matter which one.
Doesn't matter which one. So I know you don't want to, but let's do this again, but we'll kill the x's first. Oh, shit. All right, so what do I have to do in order to kill the x's? If I just am really like hating x, and everywhere I can, I kill it. How do I kill these two? What do I have to do?
Multiply the top by 5.
Yeah, now it's an LCD kind of idea. I can't make 3 become 5 easily. So I make 3 and 5 both become something. Now if I multiply this guy by 5, I get 15x plus 5y equals negative 10. It's not a bad idea to write that everywhere because people forget to multiply this side. What do I have to multiply this guy by? Negative 3. So put in negative 3, negative 3, negative 3. So I get negative 15x. That's why I had to do that. So now these two will kill each other. Negative 3 times negative 2 is plus 6y. Negative 3 times negative 7? Positive. I love it. Shoop. Die. 5 and 6 is 11. Negative 10 and 21 is 11. Y is 1, which is what we got before, right? Is that cool? And I'm not going to do it again, but if you plug a 1 in, you'll get negative 1 for x, just like we got before. So it doesn't matter which variable you kill first, what you solve for if you're doing substitution. None of that matters. Just very often it's going to be an easier way to do it.
How are you doing if you have more than 2 equations?
I love it. We're going to get into that after this next test, after this Thursday. The immediate thing we get into next is what if I have 3 things I don't know? Then I need 3 equations. So people are laughing, but that's what we're going to do. We got to think, what does that mean geometrically? I'm not going to even talk about it right now. I don't want it infiltrating our thought process yet. Yes?
So like number 4, you would multiply the x by 4.2 in the green book.
Oh. Did I bring it? Yes. Yay. 4.2, number 4. Multiply the second one by, no, by negative 2. So that they'll be opposite signs. Yeah. If that one's a special case, you'll end up with 0 equals something. Okay. Okay, so let's take a step back. We got to do section 3A now. It's the one last section we got in chapter 3 to do. I set that aside for a little while. You guys hoped it would become forever, but no. Function. Function, junction, what's your function? Junction. I'm just a bill. You know, you guys grew up on the what? You're right. Did I freak you out? I won't sing. I'm a math teacher. We shouldn't sing. What? Was it that bad? I don't care. So there is an idea of a relation in math. It's a relationship between variables. So for us, we're going to keep it to be 2 variables for now. So everything we've really looked at, so this is a relationship between x and y. Certainly it's different than we're used to, but that's still valid, right? That's a relationship. This is a relationship. Those are all relations. Okay. In order to be a function, you have to be such that for every input. Okay, so here's what a function is. Function is a relationship where every input, x is normally the input, right? There's only one output. Has anybody ever heard of like Highlander? Yes, there can be only one. So for every X, there can be only one Y. For every input, there can be only one output. Now this makes physical sense. If I threw a ball, so if I throw a ball and the position looks like this, the function might look like some kind of a upside down parabola, blah, blah, blah. Blah, 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 blah. So we're going to learn this later. So this is a parabola. It's got a square in it. I know some of you guys know that already. Okay, so if I throw a ball in the air, it's going to follow this parabolic arc. Right? Sort of like we saw with that dart thing the other day. If I ask you, 2 seconds after it's thrown, where is it? And you tell me it's 7 feet up and it's 3 feet under the ground, I'm like, that's a flippin' magic ball. We got to get that thing back, right? I can't have 2 outputs for an input. So there's no way at time t equal 2 seconds that this output can be 2 different things, right? If I said, what size shoe are you wearing on your left foot? You can't tell me 7 and 11. Right? There's no way. I'm very careful now because people can have actually different size feet. They could have a 10 there and a 10 and a half there. I understand that. But on your left foot right now, you're not wearing 2 flipping shoes. There could be only one output for that question, that input. Are you guys semi with me? So the idea of function is actually tied to what makes physical sense. Okay, maybe. All right, so let's explore what this means a little bit, and then we're going to move into the green book because it's got some nice pictures in there. Or, usable pictures anyway.
Are we going to have to know that definition for?
Yes. Now, I don't ever ask you a definition question. I never say define function. But the more you understand what the function definition is, the more sense all the tests for seeing if it's a function works and why it works. Yeah. Okay, so let's do this. So the whole idea of functions for every x, all right, let me write this again, for every x. And what are all the x's called? All x's that can be used, they're called the domain. So the domain is the collection of all the x values I'm allowed to use. Certain functions will have certain things that will make the bottom 0 or something. You have to throw those out. You say, that's not in my domain. So for example, what x would make this have a 0 on the bottom? 1. So the domain of this function does not include 1. The domain of this function is everything except 1. I like it. So domain is all the values you're allowed to plug into x, all the x values you're allowed to use. The y's are related to the range. So the range is all the outputs you can get. I like it. Domain is all the x's I'm allowed to use. The range is all the output values for y that I get. How are we doing so far? So let me give you a nice visual of this idea. Or, nice for me. Let me be very nice and Fisher-Price-ish in my drawing, considering how sucky I am at drawing. So say I have a function that does this. Yeah. Oh, Jeff, you made it all too easy. There you go. Oh, I can't do that. That's interesting, dude. Say I have something that does this. Sure. The domain is all the x's that have an output, all the x's that were used. What's the smallest x that I used? Negative 2. So the domain is everything from negative 2 up to, what's the biggest x that has an output? 3. So it's always this little dude walking on the x-axis. Where does he see the picture? Sees it at negative 2, and then he loses it after 3. What about the range? The range is just do the same damn thing except on the y-axis. Where's the first place he sees it? -2. And what's the last place he sees it?
Positive.
I'm trying to make it 1. So domain, all the x's that have actual outputs. Range, all the outputs.
And you use bracket because it includes.
Yes, if I would have put an open circle here or something, then it would have been a parenthesis. Because that would have meant I didn't use that. I like it. But otherwise it's closed circle, bracket. Chickens, the ass in. Okay. So let me show you this. Keep in mind the definition of function. So here's one way I can show you a function, or like a relation at least. Is this a function? So let's see what the hell this means. When I put a 2 into this thing, what do I get out? 1. See, that's the domain. That's the x value. That's the y value. Is this a function? Does it match the definition? For every x, is there only one y? No. Which one has a problem? That. Because that x goes to more than one y. It's like me saying to somebody, hey, fourth person, how many TVs are in your house? 5 and 9. Who the hell are you? What? 4 of them sometimes. No. You got so many TVs. Not this weird in phase and phase out. So does that make sense? That picture. That's one way I can show you. So to show you a relationship to a function we know. If my function was the square function, it squares everything. Right? It's this function that squares what's put into it. Where would these go? What would the range be for this?
1, 4, 9.
Okay, so this picture, I didn't tell you what the function was. I'm just telling you what it does. It takes 2 to 1, it takes 3 to 5, and it takes 4 to 5 and 9. Now, believe it or not, there are things that will do that. They're not functions, though. I think this is not a function. Why? There's an x that has more than one y. I like it. Some of you guys hate it. All right. How else can I show you a function or a relation at least? Is this a function? See how these are almost the same? Couldn't you make wouldn't this be the 0.21? And this would be the 0.35, 45, 49. So what are you looking for? Here you're looking for arrows that are coming off this one thing. 2 arrows coming off the same thing. Here, what are you looking for? Is there any x value that goes to more than one y value? No. 1 only goes to -2. 4 only goes to 7. 6 only goes to -2. I know -2 is used twice. Who cares? There's no x that goes to more than one y.
So one of the other points is like 1, -3. That
Yeah.
would be
So this is a function. So tell me that. Do it again.
it was 1, -3 instead of 1, -2.
That would still be a function. So to make it not a function, I'd have to use 1 again. Now that is not a function. Why? Because there's an x that goes to more than one y. There's an input that has more than one output. Yes?
So it's only a function
If there's no x that goes to more than one y, every x has to go to only one y.
but the y can have like 2 of the same.
Yeah. So why is this a function? Because 1 only goes to negative. Does 1 go to anything else? No. Does 4 go to anything else than 7? No. Does 6 go to anything else than -2? No. So again, does it make physical sense for this book to stay right there where it is? All right, let me start time. So at 0 seconds, it was, let's say, 2 feet off the floor. At 3 seconds, where is it? Where is it? 2 feet off. At 12 seconds, it will be 2 feet off the frickin' floor. So every time, every input had the same output. Does that make physical sense? Yeah, it's just frickin' sitting there. So it's okay for it to have the same output, right? It's like a fish, flying fish. At 1 second, it was 2 feet under the surface of the ocean. Then it jumped out of the ocean, and then it's 2 feet under the ocean again a little bit later. That could be what this represents. That makes physical sense. No problem there. But if that fish was 3 feet under and 4 feet over the I'm like, what kind of fish is that? It's like, I exist in 2 places. What the shit? What kind of fish? I don't know if I want to catch that. I'm not sure. I'm not sure. I want to bring that on my boat. No boat starts going, I don't know. All right, I watched too much science fiction. Now, finally, the visual interpretation of the definition of function. Shit. It's a lot of shins. Here's what this is like visually. Can somebody explain to me why this thing is not a function? This is not a function.
Sideways.
Be more specific.
Isn't it when you draw like lines across the...
Yes. So there is an x value that goes to more than one y value, isn't it? For example, this guy, or even this guy. He's here, and he's here, and he's here. Now, if I connect those points, what kind of line do I make? Straight line. Yeah. I love that. A vertical line. So make a line. What kind of line is a line? All right, we got a line. So the visual interpretation of the definition of function is vertical line test. If a vertical line, and what does a vertical line represent? An x value. What's the equation of this vertical line? X equals 2. So that x value, if it hits the graph more than once, it has more than one output. That's exactly the definition that says no, not a function. So to be a function, it can't come back on itself like this, right? It can do this. It can go wee. That is a function. There's no vertical line that goes through more than once.
Isn't that called the pencil test?
No, you're thinking about continuity. Thanks for playing. That's a calculus idea. Oh shit. I like that.
Like, yeah, my algebra teacher in high school said, like, put the pencil on the line and just run it across, like, perpendicular.
Oh, I see, okay.
And then it
All right.
hits it.
In calculus, there's an idea of continuity that uses a pencil to learn. All right, so I don't blame you. But yeah, you mean like this, and then if you see it go through, so that's just that same idea. Yeah, your pencil is acting like the vertical line. Yeah, okay, I like that. I could deal with that. Okay. Now, that's the first piece of functions. That was the first piece, was the definition. We talked about the definition. We used it in a lot of different flipping ways, but it was just the idea of definition and what it looks like in all these different representations. Oh, shit. You guys doing all right? Some of you guys look... I'm sorry. All right, well, here's this next part of functions is what they look like algebraically, like if I write them out. Here's function notation. Section 3A.
Is that an F?
Yes. That's the fundamental letter we use for functions, because again, math people are very creative. Let's use F for function. But if I have a function that represents my profit at a company, I would call it the P of X function. If I have a function that represents the number of people that attend my concert, N function, so forth. So we can go beyond just F. But F is if it has no real physical meaning yet. I'm just playing with it. I call it F. And if I have another function laying around, I call it G. If I have another function laying around, I call it h. It's crazy. Now, so really, all f does, what would normally be here? Y. So these notations, they just take the place of y. If each of these were y, and I said plug a 2 in, you'd be like, which one do you want me to plug a 2 in? But if I ask you, what is f of 2? Which one am I going to use? Holy shit. The f function, right? What does this say? So that's how you read this. F of x. F of 2. So fundamentally, functional notation is just substituting stuff. What does this say? When x, whatever x is, I'm going to put it here. So what do I put there? A 2, and then I figure it out. Bless you. It's just substitution. So this is like f of x is this, is how it's built off of x. If only I knew what x was, I could put it there and figure out what, so what is it?
5.
Yeah, 4 plus 1, 5. What point does that function go through? It goes through the point 2, 5. See, that's the other level of niceness. I can actually see the point. 2 is what I plugged in, 5 is what I got out, so it goes through 2, 5. Yes, ma'am.
So is that 5 of the y now?
It's beautiful. Because again, f of x is the y. So this is the output, that's the input. It's kind of nice. That's the input, it's in. It's in it. And that's the output, that's what came out at the end. I like it. So here, let me ask you some more questions on this. Here, try to do this on your own. What is h of 3? And what is g of negative 5? So do those two.
Oh, you can just plug it into the equation.
Same problem, yeah. This one, continuing over there. You're all like, be careful. Do you guys notice this is not h times 3? When I get to this point, f of 2